Jai Hind. My name is Pardeep and I am working as an assistant professor in IT department in Ajay Kumar Garg Engineering College, Ghaziabad. So today we'll going to discuss the subject theory of automata and formal languages. In short, we can call the subject as TFL. Okay. So just keep that point, that TFL. Okay. And the subject code is KCS 402. Fine. Now, so today we will discuss deterministic finite automata. In the previous lecture also we have seen all these 5 quintuples, that Q is finite and non-empty set of finite state, sigma is the input alphabet, delta is the transition function, Q naught is the initial state, and F is the set of final state, which is a subset of Q. Okay. So in the previous lecture we have construct some DFA. Fine. So we will continue some more DFA. Now see the next problem, that construct the DFA over sigma equal to a comma b, which accept set of all string starting with a. Set of all string starting with a. So here sigma equal to a comma b and language will be that it contains set of all strings starting with a, only a. Okay, a b, a b a, okay, a b b, a b b a, and so on. Okay, up to infinite. Okay, now so this is the required language. So we need to construct the corresponding DFA. Okay, corresponding DFA for that. Now construct the basic DFA to construct the required DFA. So Q naught is the initial state, start with A. Now this is my basic DFA. This is not actual DFA, it is NFA. Okay. Now it states that it accepts set of all strings start with A. So it start with A. Okay. On it reaches to final state QF. At QF there can be any number of A and B. Okay, there can be any number of A and B. Okay. Now still this is not DFA because at Q naught B is not defined. Okay, at Q naught B is not defined. So if we apply B here, then it will violate the condition start with A. So Q naught on input B goes to dead state. Q naught on input B goes to dead state. Dead state or trap state. Okay. So this is the required DFA. This is the required DFA. The regular expression corresponding to this DFA will be A plus B star. Okay. So this A and this A and B loop A plus B star, any number of A and B, but the condition start with A satisfied. Now next is the next question. Now construct the DFA over sigma equal to A comma B, which accepts set of all string containing A. This is very important, containing A. Many question asked on this question pattern, so this is important, so make a note of it. So this is important. Okay. So one more thing you need to note that if containing word mentioned in DFA construction, then there is no dead state. This is very important. Just need to remember, if containing word mentioned in the DFA, then there is no dead state in DFA. Okay. Now let's construct the DFA. Here sigma equal to A comma B, and the language will be containing A. So only A also comes in the language. Okay. A and B comes in the language, B and A. Okay. A. Okay. Containing A, this is very important. Containing A means minimum one A. There can be more number of A, but at least one A must be present. B, A, B, A, B, B, A, and so on, infinite string. Okay. So we need to construct the DFA corresponding to this language. So we know that there is initial state, we denote initial state by Q node, and this shows that, this arrow shows that initial state. This arrow does not comes anywhere. Okay. This is just symbolic notation that our automata machine starts from Q node. Okay. Now containing A, so on A it goes to state QF. Okay. So this is my NFA. Okay, this is my NFA. This is not DFA. Why? Because at Q node B is not defined, and at QF A and B also not defined. Okay. So now on A and B it goes to QF only. Okay, we can write it. Okay, here at Q node there is no condition that it will start from A. Okay, it states that containing A. So A is contained at Q node. We can write B. There can be any number of B. Okay, so this is my DFA. At Q node A and B is defined, and at QF A and B is defined. So okay, so this is the required DFA. So this is the required DFA. Okay, we cannot transit this P to dead state. Why? Because it will not say that string cannot start from V. It can start from V. Suppose let's take one example. Suppose W is equal to B A B. It will satisfy the language condition because it containing A. So on B it goes to Q node, on A it goes to QF, and on AAB it remains in QF. So this string will be accepted. Okay, this string will be accepted. Right. Now let's see the next question. Now construct the DFA over sigma equal to A comma B, sigma equal to A comma B, which accept set of all string ending with A. Contain the set of string ending with A. Ending with A. This is the only condition. Okay. So the language will be, it is something like that: A only, B A only, A only, because ending with A, this A only, A start and end with A. B A, this string is also ending with A. B A B A A. This string is also ending with A. B A B. This string does not comes into the language, so this is not in the language. Okay. Now P A A A. This also comes into the language. Okay. So, and so on. And so on. Right. Now we need to construct the DFA for that. So there is initial state Q node. It says that ending with A. So this is the basic block of to construct the DFA. This is an NFA. Till now this is not DFA, it is an NFA. Now it will accept only one string A, and this will end with A. On QF, if I make a loop, now this also end with A. This also ends with A, right? On B also we define on Q node. On if I am at state Q node, on input A I goes to QF, and on B, okay, this will not be accepted. Okay, so I can't write B here, so this B cannot be written here because on input B we go to state QF. So just erase that. Okay, now say this state end with A. I can write B here, this loop here. Okay, now this is correct. Now any number of B, then A end with A accepted. Now any number of A, any number of A accepted. Now if B comes, then move to backward this B. Okay, now it will accept all the string ending with A. Okay, suppose let's take some example. Okay, let's take some example. Some string W equal to A B A B A. Q node on input A goes to QF. QF on input B goes to Q node. Q node on input A goes to QF. QF on input B goes to Q node. Q node on input A goes to QF. Upon scanning the entire string, I am at the final state. Okay. Suppose take one more example. A B B. Q node, I am at Q node. On input A, I am goes to QF. QF on B, I am goes to Q node, and Q node on B goes to Q node. This is the non-final state. This is the non-final state. This is the non-final state. So this will not be accepted. So this string will not be accepted. This string will be accepted. This is not accepted. Okay. Now see the next example. Construct the DFA over sigma equal to AB, which accepts set of all string containing AB as substring. Containing AB as substring. Okay. So sigma equal to A comma B. Now the language will be AB must be present. In every string of language, AB must be present because AB must be present as a substring. So only AB, this is in the language A, B, B. So AB is here. Okay. Now A, B. this is also present. A, B, B, B. Now AB is present here. Okay. BA, BA. See, AB is present here. Okay, and so on. So it will contain all these string which contain AB as a substring. Okay. Now construct the DFA. So Q node on A goes to Q1, Q1 on B goes to QF. Okay. Now AB is present here. AB is present here, but this is not DFA. This is not DFA. Okay. Because at Q node B is not defined, at Q1 A is not defined, and at QF AB is not defined. So if I write AB as a loop, then there will be no problem. Okay. Now still now AB is as a substring. Okay. Now if I make a loop here, okay, B, any number of B and AB, still AB is a substring. Now at Q node A and B is defined, at QF A and B is defined, at Q1 suppose A is there. So B, any number of B, see here, any number of B, A, any number of A and B, and there is any number of A and B, A plus B star. Okay. So here if star is 0 then still AB, if 1 then still AB. So AB is present here. Okay, AB is present here. So this is the final DFA for the corresponding language. So this is the final DFA for the corresponding language which contain AB as a substring. See the next example. Okay. Now construct the DFA or sigma equal to A comma B which accepts set of all string ending with AB. This is very important, ending with AB. In the previous question it is containing AB as a substring. See here the word containing is used, so that's why there is no dead state. Okay. Now ending with AB, fine. So here sigma equal to A comma B and language will be AB only, A B, this end with AB, B, AB, this string also comes into the language, end with AB, A, B, this is also end with AB, B, AB, this also end with AB, and so infinite times. Okay. So construct the NFA because construction of NFA is easy as compared to DFA. So first we construct the NFA. We start from state Q node that end with AB. On A goes to state Q1 and at Q1 on input B goes to final state. Okay. Now this is NFA, this is not DFA. Now the basic question is end with AB. Okay. If I make a loop here, then there will be no difference. Still it will accept all the string that end with AB. Okay. Now change the color. Now at Q1 A is not defined. At Q1 A is not defined. If I make a loop on it, okay, now still end with AB. A n times of A and B still end with AB. Now Q node is defined, Q1 is defined. Now at QF, if I make a loop of A here, now it will end with AA or BA. So this is not correct. Or if I write it as only B instead of A, if I write only B, then it will end with BB. So this is not correct. So just remove it. Now QF on input A goes to Q1. So if A comes after QF, still A then goes to B. So it will end with AB. This condition will be satisfied. Now transition B still remain. Now if make a transition here B, now end with BB. So this is not correct here. So we remove this one, this B from here. Now make this transition is B here. Okay. So this is the complete DFA that end with AB. Okay, end with AB, right? N times of B, A, N times of A and B. Again AB, end with AB. Now if B goes to state Q node, then A and B, and A, N number of A and B. Okay, so this is the final DFA for the required language. Okay, thank you.